Seamless travel is one of the most ambitious goals in aviation history. But what does it actually take it to make it real? Not in theory, but operationally. That's what we'll explore together today. Step by step, we will look at the architecture behind seamless travel, from the documents we use to the systems that verify them. Hello, my name is Arif Mamedov and I'm the CEO of Regular Forensics. I lead our operations and strategic partnerships across North, Central, and Latin America. I'm also heavily involved in Regular's global operations. I work closely with agencies like US Customs and Border Protection, the Department of Homeland Security, and the Department of State. For the traveler, seamless means invisible. They don't think about processes, systems, or checkpoints. They just move. By 2029, over 1.27 billion people will be using digital travel identities. But that doesn't happen by magic. It depends on a complex web of hardware, software, and standards working all together. So let's look at what it actually takes to make that experience possible. When we talk about seamless travel, it is easy to imagine just speed and convenience. But in reality, it is more than that. It is secure by default, enabled by biometrics, and trusted documents. It is intermodal because your journey doesn't stop when you switch from train to plane. It is digital and smart, replacing paperwork with apps and sensors, and it is tailored to passengers with different needs and expectations. Finally, it is built for sustainability to support better flow and greener choices. Seamless travel is not a single feature. It is the sum of all these elements working together smoothly in the background. Let's take a step back and look at the bigger picture. Seamless travel is not a concept developed in isolation. It is part of the broader global effort supported by key international organizations. ICAO defines the travel document standards used worldwide, including DOC 9303. Now it sets directions toward digital travel credentials as a future-proof identity credentials. IATA promotes One ID initiatives to streamline identity across the aviation ecosystems. World Travel Tourism Council, WTTC, is advocating for globally interoperable identity frameworks. ACI, Airport Council International, supports the use of biometrics at airports to improve the passenger experience. National governments also are running pilot projects, from digital travel credentials trials in the Netherlands and Finland to mobile driver's licenses and electronic IDs implementations in the US and Germany. The global alignment shows there is both vision and traction behind seamless travel. How identity is actually used across the passenger journey? It starts when the passengers book their tickets, usually by entering their ID data. Then, during check-in, that identity is confirmed, either via an electronic ID or through a digital travel credentials, depending on the setup. At the backdrop or kiosk, we start to bring in biometrics, typically face capture, which gets matched in the backend to the travel document. Then comes security screening. Some countries rely purely on boarding pass checks, others already do the biometrics verification here. Next we have border control. That's where the passport is verified using biometrics and cryptographic methods, or a digital travel credential if it's supported. And finally, boarding. Ideally with just a face match and no need to show documentation again. Each of these steps needs to work together securely and seamlessly to maintain flow, and that's where identity infrastructure becomes very critical. To design seamless travel, we need to start with the basics, the documents. Not all IDs are created equal. Only e-passport and digital travel credentials are ICAO compliant and accepted for the international travel. The rest, like electronic IDs, mobile driver's licenses, and electronic driver's licenses, can be useful in specific domestics or pre-travel steps, but they don't follow global standards and are not interoperable across the borders. So whenever we talk about automation at the border control or using digital identities for travel, we are really talking about ICAO standard documents. That's what the infrastructure is built to support. As I mentioned, not all digital IDs are created equal, and that really matters when we talk about cross-border travel. Let's break it down. Electronic passports or e-passports are the current standard. They are ICAO DOC 9303 compliant, globally accepted, and rely on contactless NFC chip. That's what border control is built around today. DTC, digital travel credentials, carry the same data as the chip in the e-passport, but live on a mobile phone. They are being piloted now and follow ICAO digital travel credentials core principles. Then there are electronic IDs and mobile driver's licenses. Those are national programs not designed for the international travel. They're used in the pre-travel stages like online check-in, but aren't interoperable or standardized across the countries. So if we want systems to talk to each other globally, the type of documents and how it's built makes all the difference. Let's clarify a common source of confusion: the difference between IATA's One ID and ICAO's Digital Travel Credentials, or DTCs. These two initiatives often come up in the same conversations, and while they work well together, they are fundamentally different in purpose and design. One ID is an industry-led framework for using biometrics to streamline identity checks across the passenger journey. It is not a document, it's a process concept. Think of it as the choreography that coordinates different touchpoints from the backdrop to boarding using a biometric token. DTC, on the other hand, is a standardized digital travel document. It contains the same secure data as the chip in your passport, just stored on a mobile phone. It is issued by government, not airlines, and is designed for border control and travel. So, One ID is about how identity is used across the journey. DTC is what the identity actually is, cryptographically secure and ICAO compliant. And yes, a DTC can be used within an One ID flow as the identity source. By the way, Regular now supports DTC standard end-to-end. With our document reader SDK, you can both create and verify a virtual component of DTC using the data from ePassport or validate an incoming DTC from a phone or a server. For example, the updated SDK can read the RFID chip on ePassport and generate a virtual DTC, recognize and verify a DTC VC with a smartphone or passport reader or via secure retrieval, read a physical component of digital travel credentials, DTC PC, and verify its content offline using the PKD trust chains. So from the issuance to validation, both server-side and on a device, it's all covered. It might look like a quick scan at the gate, but behind it's a pretty complex setup. There is an input layer like kiosks, readers, and apps. That's what the passenger sees. But then the verification layer, where the IDs is checked, biometrics matched, and liveness confirmed. And finally, the trust layer, the backend logics and the connections to trusted sources to make the whole thing reliable. All of that needs to work together smoothly for just one seamless moment. When we think about document verification, it is tempting to imagine a single scan and a green check mark. But in reality, building the trust from a document, especially in a border control or aviation context, means orchestrating multiple components across several layers. At the input layer, a passenger presents one of many possible identity documents, from an e-passport to a mobile credential via kiosk, a gate, or even a mobile app. Then, behind the scenes, we enter the verification layer. This is where real-time checks happen: biometrics matching, liveness detection, chip reading, and the cryptographic validation. Each of these steps is critical. If any one of them fails or incomplete, trust can be established. Finally, there is a trust and orchestration layer. This part often gets overlooked, but it's where the system makes sense of everything. It checks certificates against trusted sources like ICAO PKDs, log the session, calls external APIs if needed, and ultimately makes a decision: do we trust this identity or not? This architecture needs to be fast, resilient, and privacy aware, and all of it has to happen within seconds, often in a self-service flow. So yes, it's complex, but this is invisible machinery that enables that seamless passenger experience we're aiming for. When we talk about building trust in digital identity, cryptography is what makes it possible, especially when we are dealing with the chip-based documents like e-passport and digital travel credentials. This is what happens under the hood. First, the data on the chip is verified through what's called passive authentication. The signature is checked against the CSCA certificate. Then chip authentication or active authentication ensures the chip itself hasn't been cloned or tampered with. The system also confirms that the terminal doing the check is authorized. That's terminal authentication. All of this relies on the global trust frameworks like the IK-opaque ID, master list, and certificates revocation list. The result, a document is either verified, rejected, or referred for manual inspection. And all that happens in the background in seconds. Now that we have seen the passenger flow from the end to end, let's take a closer look at the technical blocks that make it all work behind the scenes. To make seamless travel possible, the system relies on a wide range of devices, from biometric kiosks and facial recognition cameras to passport and NFC readers. These devices are deployed across multiple touch points to capture and verify identity quickly and securely. What's important is that all of them must meet strict international standards, especially ICAO requirements, since we're dealing with the official travel documents and sensitive biometrics data. In other words, hardware isn't just about capturing an image or scanning a document. It's a critical piece of the identity validation pipeline. Let's illustrate the types of hardware used to verify identity documents at the airports and borders. Regular offers a range of document readers, from compact embedded models for kiosks and e-gates to mobile, field-ready devices. Key capabilities include multi-light imaging, visible IR in ultraviolet, RFID reading, barcode recognition, and chip authentication. Some models, like the 7424M, are also capable of reading digital travel credentials from mobile phones via NFC. These devices enable reliable automated capture and verification of document data in real-world conditions, even under glare, poor lighting, or document wear. Backend and orchestration layer is where all the real work happens behind the scenes. Once biometric and document data are captured at the front end, it is routed to the IDV platform that acts as the orchestration layer. Here, cryptographic validation kicks in, typically via IK-opaque ID, to ensure the document hasn't been tampered with. Then we run real-time biometric matching and liveness detection to confirm that the person presenting the IDs is who they claim to be. All of this fits into decision logic engine: match, no match, retry, or escalate. And of course, everything is logged for audit and compliance, with options for manual review when needed. So while the passenger seems a seamless, fast experience, under the hood, it is a highly coordinated and layered system. Behind every seamless identity verification process is a set of well-established standards and protocols. This slide shows some of the key ones that ensure interoperability, accuracy, and trust across systems and countries. First, we have the ICAO Doc 9303, the backbone of travel document standardization, defining how electronic passports and similar documents should be structured and read. Then there is a DTC core principles, which guide how digital travel credentials are structured and verified. ISO 3979 4-5, which comes into effect in 2026, introduces biometric data format standards, especially important for the facial and fingerprint data exchange. We also rely on standardized data formats like JSON and XML for interoperability between systems, and API protocols like REST or SOAP for secure communications between components, whether it's document readers, orchestration platforms, or government database. Together, these standards form the technical foundation that allows multiple players to work together in a secure and coordinated way. As ISO 3979 4-5 standard officially comes into effect in 2026, we're already seeing the ecosystem starting to prepare. At Regular, we implemented support for this new DG2 data format aligned with the standard. That means we're technically ready to handle identity documents issued under the updated standard, both in terms of data structure and interoperability. This early alignment helps ensure smoother transitions for our customers and better data integrity across systems as adoption ramps up. It's time to look deeper into the biometric side of seamless travel, both the technologies involved and the security aspects that makes them trustworthy. Active liveness detection adds a critical layer of protection against presentation attacks. Regular solution follows ISO 30107-3 Level 2 and uses guided actions to confirm the user is real, not a spoof. Each session is unique, making it harder for attackers to reuse the same approach. This makes the enrollment process not only more secure, but also more resistant to advanced fraud tactics. Face comparison one-on-one. This is where the passport photo meets the real person. Regular Face SDK compares all available images from the chip, printed portrait, selfie, even ghost images to verify that the person in front of you is the one who they say they are. It works instantly and integrates directly with our document reader, so no extra setup is needed. In addition to one-to-one comparison, Regular Face SDK also supports one-to-N identification. That's one face matched against many. You can use it to check if a person is already in your database or to search across customs groups, for example, a list of flagged users. Photos can be stored with names and grouped in any way you need. And most importantly, there is no limit on the database size and no slowdown in search, even with millions of records. When we talk about biometric capture, there is no one-size-fits-all device. It all depends on the context, where we're dealing with a high-traffic airport checkpoint or a remote border crossing. That's why there is a multiple hardware categories working together. Fixed biometric cameras at counters or e-gates provide consistent ICAO-compliant images, while mobile kits are used for in-field checks are built for portability and rugged use. Embedded modules go into the e-gates or mobile apps, and multimodal scanners capture several biometric trails in one go: face, fingerprint, iris, all in a matter of seconds. Each of these plays a role in keeping the process fast, secure, and adaptable to different operational needs. When we talk about deploying identity verification at scale, especially when biometrics and sensitive data are involved, the choice of deployment model becomes crucial. Each option here has a trade-offs. On-prem offers maximum control and is the go-to solution for border agencies and government programs. However, it comes with the infrastructure overhead. Private clouds offer more flexibility, even though latency and vendor dependency can be concerns. Public cloud is great for scalability, but rarely meets data sovereignty requirements in aviation. The hybrid or edge deployments are increasingly common, especially when fast local processing like biometric pre-matching is needed. The key is choosing what fits the trust, control, and speed needed for each travel flow. These layers are often invisible to the passenger, but critical for public trust. Identity verification relies not only on technology, but on the robust compliance with data protection laws. GDPR, for example, requires transparency, accountability, and proportionality. We must ensure that every seamless journey is also a secure and lawful one. Let's look at where seamless travel is already happening or at least being actively tested. In the UAE, passengers can go through the journey using just their face, from check-in to boarding. It's already deployed in Dubai and Abu Dhabi airports. The Netherlands and Finland are running DTC pilots for the international travel, experimenting with what a document-free journey could actually look like. In the US, CBP's Global Entry and Simplified Arrival programs use facial recognition to speed up entry while maintaining the security. The UK and Germany are working on digital ID use in travel, mobile driver's license and EIDs respectively, especially for domestic routes and automation at borders. And in Singapore, e-gates and facial recognition are tightly integrated with backend system, which is a great example of technical orchestration in action. So it's not just a concept. Pieces of the seamless travel vision are already in production around the world. The concept of seamless travel sounds great in theory, but getting there is far from simple. There are still major obstacles we need to overcome. First, lack of standardization. Different countries follow different rules, formats, and infrastructure timelines. Infrastructure gaps are also real. Not every airport or border crossing is ready for biometrics or digital ID-based travel. Then there is a legal and privacy landscape. Requirements vary significantly across jurisdiction, and that slows down the deployment. Also, despite all the innovation, digital documents adoption is still low in many regions, especially when it comes to the ICAO compliant formats like a DTC. And let's not forget about trust framework. They are essential, but not yet universally accepted or implemented in the coordinated way. Finally, we're still dealing with the legacy systems and poor interoperability. If your backend cannot talk to the border control system on the other side, seamlessness stops right there. So even though the concept of seamless travel is being piloted, a lot of foundational work needs to be happen before it scales globally. On the left of the slide, you see the challenges around the coordination and interoperability. National systems don't always talk to each other. Standards exist, but they are not adopted on the same pace or interpreted the same way. And trust, especially across borders, is a major sticking point. Even with verified data, many governments hesitate to accept what is issued elsewhere. On the right of the slide, we have more practical and policy-related blockers. Airports often run on legacy systems that cannot support newer formats. Consent and privacy regulations are still catching up, especially when biometrics and digital identity are involved. And while digital travel credentials are promising, they are still not deployed at scale. There is no unified global plan yet. So where the vision is clear, the path still requires collaboration, standards alignment, and trust building. We have seen that the vision of seamless travel isn't something abstract or far off. Many of the core components, from trusted identity documents to biometric infrastructure, already exist and are in use. The challenge now is how to connect the dots, align standards, modernize infrastructure, and build the trust needed for global adoption. At Regula, we contributed to that shift through strong verification tools that support interoperability and security without losing sight of the travel experience. It's a big task, but progress is already happening and it's closer than it seems. Seamless travel, it's not a science fiction, it's just solid infrastructure. The pieces are already here, and now it is about putting them all together. Thank you for taking this journey with us, and thank you for watching this presentation.